in this lecture, we will see some examples using different styles of modeling in VHDL. So I'll proceed further. First, we are designing the AND gate. So what is an AND gate? Like AND gate is having two inputs, like A and B are inputs of AND gate, and it will give the A dot B as an resultant output. So like you can see here, the truth table of AND gate. When A is 0, 0, A and B are 0, 0, then output is 0. When A and B are 0, 1, then output is 0. When A and B are 1, 0, then output is 0. When A and B are 1, 1, then output is 1. So why this? We can say for the AND gate, for the input to be when any of the input is 0, then the output will be 0. Like when A is 0, then output is 0. When B is 0, then output is 0. When both inputs are 0, then output is 0. So we can say that for AND gate to output to be 1, the all the inputs should be 1. So here we are using writing the code of AND gate for using the process statement. So first of all, we will import the IEEE library, and after that we will design an entity. So AND gate, this is our entity name. So this is our entity name, and after that we have declared the port, like A is an input port, B is an input port, and C is an output port. And after that we will end the entity, and as you know, after entity in VHDL we write the architecture. So we use architecture behavioral for the AND gate, and we will begin our architecture and process AB. Like process is a statement, and in this statement, in the brackets we write the input variables on changing which our output get affected. Like when we change any one of the these two inputs, like when we change A or B, change B, or we change both, so our output will also change. So in this process statement, I want to explain. I want to say that in this process statement, we only write those input variables in those input variables for which when we change them, our output is also changed. So we will begin our process, and after that we will define the logic of AND gate, like A and B. We simply end the operation and restore the result in the C variable. So and after that we will end the process and end the behavior. Like that we can implement our AND gate using process statement. So hope it is clear to you. And this is the entity diagram of AND gate. Like when you simulate this code in Xilinx software, so after the synthesizing of code, when we will see click on view RTL schematic, there is the option of view RTL schematic. Then you will see first this entity diagram. Like A and B are input and C is an output. And when you double click on it, then the internal architecture of this will open. Like this is called RTL schematic. So here A and B are input and C is an output. Like A, I0 and I1, you can see here, these are internal values of AND gate. Like it is taken A as I0 and B is I1 and O as C. So like means I1 means input 1, I0 means input 0, and O means output. I think this will be the indication of this. So moving on the next slide. In the example 2, we are implementing the OR gate using if else statement. So you will ask like why we are using if else statement for OR gate. Like can't we do that like we have done in previous example for AND gate? Yeah, you can do that, but I was my main motive for this is that I will tell you that how to use if else statement. Okay, so first of all I will tell you what is OR gate. So OR gate is when you can see here, A and B are the inputs of OR gate, and A plus B will give the result of output of OR gate. So when input A is 0 and B is 0, then output will be 0. Or when input A is 0, out B is 1, output is 1. When A is 1, B is 0, then output is 1. When A is 1, B is 1, then output is 1. So in this we can say for OR gate, like when any one of the input is 1, then the output of OR gate will be 1. So like the previous example, first we import the IEEE libraries, uh, and after that we declare the entity, and our entity name we gave like OR gate or underscore gate. So and as AND gate, similarly, OR gate has two inputs and one output. So A is an input port, and B is an input port, and C is an output port. So after that, we will end the entity, and after entity, we will use the architecture. So we will begin the architecture and process AB. So like in previous example, when A and B changes, the output C also changes. Like same in this example, when A and B changing, the output C is also changing. So in process statement, we write A and B, and we will begin the process statement. And after beginning the process statement, we are writing like if A and in this if we are simply implementing the truth table of OR gate, like if A equal to 0, B equal to 0, then C equal to 0. So simply we are implementing the truth table of OR gate by using if then statement. So after that we use else if A1 V0 then C1, and else if A0 V1 then C1, and else if A1 V1 then C1. After that we will end the if statement. Here we started the if statement, and here we end this. Okay. Then after that we will end the process statement. Here we started the process statement, and here we will end it. And at last we will end the behavioral statement. So hope this is clear to you. And moving on the next slide. So in this example, we are implementing the OR gate by using when else statement. So from here it is change. The change is like when in that case we are using the different if else if conditions. Like here first we will use C. Sorry. Here in this case also we will implement the truth table of OR gate. Like first we will write the output C equal to 0 when A equal to 0 and B equal to 0, and then we will use else statement, and else 1 when A equal to 0 V equal to 1, else 1 when A equal to 1 V equal to 0, else 1 when equal to. So when for when else we first this is the syntax of when else, how to write the inputs and outputs using when else statement, like you can see here. And after that we will end the behavioral example. So basically the main motive of this is to tell how to use the process statement, how to use the if else if then statement, and how to use the when else statement. So hope it is clear to you. And this is the entity diagram of OR gate. So, like you will see that in when you implement this code in Xilinx software. So, thank you. We will see further examples in next video.